Good morning, this is your Stats Sensei, Mr. Spensei, and we are working on two sample proportions, and this will be a confidence interval. So, a company is testing the effectiveness of a new social media marketing campaign aimed at increasing online purchases of their popular energy drink among high school students. The company has an online customer base of over 1 million high school students. The company randomly assigned, ooh, that's important, because when they tell us it's randomly assigned, that eliminates one of the conditions. Over 2,000 students to one of two groups. One group of students were exposed to the new marketing campaign, and the other group was not exposed to the new marketing campaign. It was found that 954 students of the 1,124 who were exposed to the new marketing campaign online made purchases within the week. So we have two groups, one exposed to the new marketing campaign and one not. And 954 of the 1124 who were exposed purchased in a week. Of the selected group of 1,203 students who were not exposed, it was found that 875 made purchases within the week. So let's make some notes. Make some notes right now. So it looks like we have for X1, and I'm going to say new marketing campaign, so NMC. All right. And these were exposed. And I'm going to put NE for not exposed, just so I have some way to know which one is which. So of the new marketing campaign, 954 out of the 1,124 made purchases. And for the other group, those that weren't exposed, 875 made purchases out of the 1,203. So people are making purchases regardless whether they saw the campaign or not. The question is how much. Since we're here, let's go ahead and figure out what P hat 1 is and P hat 2. Well, P hat 1 is going to be 954 over 1124. So 954 divided by 1124. And that's about 0.8487. So about 85%. So 0.8487. And for the other group, we had 875 out of 1,203. So 875 divided by 1,203. And we get 73% or 0.7273. 0.7273. And really, that's just that 875 divided by the 1,203. All right, so we're going to need to define our parameters. And we're trying to estimate how many people will purchase it after the new marketing campaign. So let P1 equal the true population proportion of people who purchase the drink after the new campaign. I'm going to put new ads. Makes it shorter. All right. The new advertising campaign. Let P2 equal the true population proportion of people who will purchase the drink without new ads. All right. So they're going to purchase it without new ads. These will be purchased as a result of new ads. And we're going to see if there's a difference or seeing if that campaign was effective. So first one, it's either going to be random selection or random assignment. In this case, or random sample or random assignment. In this case, we have random assignment. Of 1124. And that was given. The next one was a random assignment of 875. And that was also given. Okay, we have two independent groups. All right, I'm going to write down number 3, which is the n is less than 10% condition, but since we don't have to check it, I'm not going to write it down. As I'm going to say, hey, when we do 2 samples, we often have a number 3, but we don't here. So number 4, we need to check to make sure that our sample is large enough to use the normal approximation. So this is going to be N1 P hat 1. And this one's going to be N1 times 1 minus P hat 1. Over here, we're going to have N2 P hat 2 and N2 times 1 minus P hat 2. Well, we said P hat 1 was 0.8487, and our sample size is 1124 equals 1,124 times 0.8487. And that's going to equal 954. Let's check that out to make sure that's pretty close. So 1124 times 0.8487. All right, pretty much 954. This is going to equal 1,124 times 1 minus the 0.8487. So 1124 parenthesis 1 minus 0.8487. And we get 170. Now we can't stop there. We have to compare these to 10, and they're both greater than or equal to 10, so that's good. So it looks like we're large enough for the first group. We need to check the second group, and we're going to have 1,203 times 0.7273. So 1,203 times 0.7273. And I just know that that's going to equal 875, and we'll look at that in just a moment. And here we're going to have 1,203 times 1 minus 0.7273. Let's check those numbers out real quickly. So 1,203 times 0.7273. Sure enough, that's about 875. 1,203 parentheses 1 minus 0.7273, close those parentheses, and we get about 328. Once again, we need to make sure that we show the comparison, and they happen to be both greater than or equal to 10. So we're good to go there. Our formula, P hat 1 minus P hat 2 plus or minus Z star P hat 1 minus P hat 1 over N1 plus P hat 2 1 minus P hat 2 over N2. All right, our confidence level. Well, they asked us up here, they said, hey, let's create a 97%. So let's go ahead and mark that down. We want a 0.97. This is going to be an inverse norm. We're going to have to find our area, which is 1 minus 0.97 divided by 2. And we're going to choose left, second var's inverse norm, if your calculator asks you for that. So parenthesis, 1 minus 0.97, close parenthesis, divided by 2. Mean is 0, standard deviation of 1 because we're working with the z-score. And we end up getting 2.1700. And because we're positive people, we're going to write it down as a positive. All right. My experience is I tend to run out of room, so I'm going to round this and call this 0.85. I know it's not 85, and I'm going to call this 0.727 to 0.73. I'm going to round those so I have enough room to fill in this entire formula. So this is 0.85 minus 0.73 plus or minus Z star 2.17. So this is going to be 0.85 times 1 minus 0.85 over N1, which happens to be 1124, plus 0.73 times 1 minus 0.73 over 1,203. And we want to calculate our interval. So we're going to go stat test all the way to letter B, two proportion Z interval, and ask for X1. Well, X1 is 954. So we'll type that in there. And then we have 1124 for our sample size. Then we have 875. And then we have a sample size of 1203. And we make sure we have a confidence level of 0.97. And I end up getting 0.0851. So 0.0851, comma, to 0.1576. So somewhere between 8% and 15% more will purchase the energy drink as a result of the advertisement. So it sounds like the advertisement has an effect of somewhere between 8.5 to almost 16% increase. So give me a moment while I pause this and I will be right back. So we need to write our conclusion, which is going to be we are, in this case, 97% confident that the true difference in population proportions of people who will purchase the drink having seen the new campaign and those that did not see the campaign lies within the interval 0.0851 and 0.1576. All right, so what we're saying here is, well, first off, let's look back. The P1 is the true population proportion of people who were purchase a drink after seeing the new ads or seeing the new campaign. Well, we are 97% confident that the true difference in population proportions of people who will purchase the drink having seen the new campaign and versus those who did not see the campaign lies within this interval. All right. Anyway, I hope that helps. Hope to see you on the next one, and I'll talk to you later.